Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are solving example from question number 9th. And example from question number 9, we have to solve using substitution method. Means we have to find out derivative of inverse trigonometric function using substitution method. So in an example, if such type of expressions appears at that time, what substitution we have to use, that already we have written here. So let us see how to make the utilize of these substitution while solving the example. So if you are new on my channel, subscribe the channel and hit the bell icon to get the notification of every newly uploaded video. Now observe the example number first. In this example number first, what is the given function? Y is equal to cos inverse of 1 minus x square upon 1 plus x square. So observe here such type of expression appears 1 minus x square upon 1 plus x square. At that time, if you are substituting x is equal to tan theta, so these substitutions are useful to convert this expression in terms of trigonometric expression, and simplifying that trigonometric expression, we are able to convert this expression in terms of cos, and later on we are able to apply the property that cos inverse and cos will get cancelled, and we are able to convert the given function in the simplest form. And once the equation will get converted into simplest form, easily we are able to find out differentiation. So let us make the use of this substitution in this example. So just now we have seen that such type of expression is there 1 minus x square upon 1 plus x square. So our substitution is x is equals to tan theta. So now here I am substituting x is equals to tan theta. So it implies that theta is equals to, so tan on this side will become tan inverse, or in short we can say that if we are taking tan on this side we will, if we are taking tan inverse on the left hand side, we will get tan inverse of x, and if we are taking tan inverse on this side, tan inverse and tan will get cancelled, we will get theta. But लेकिन हम easy जाने के लिए क्या बोलते हैं, just take tan on this side, it will become what? Tan inverse. Actually we are taking tan inverse on both side, and by taking tan inverse on both side we have got this result. Now we are substituting this value of x in our function. See what we will get here. So y is equal to cos inverse of 1 minus, replace x by tan theta. So here we will get tan square theta, and in the denominator also we will get 1 plus tan square theta. Just simply wherever x is there, I have replaced x by what? Tan theta. So now here we can observe that 1 minus tan square theta upon 1 plus tan square theta is nothing but value of what? Cos 2 theta according to double angle formula. One of the value of cos 2 theta is what? 1 minus tan square theta upon 1 plus tan square theta. Means using this substitution we have converted this algebraic expression into trigonometric, and this trigonometric expression can be solved applying our formulas in trigonometry. Means we are able to apply half angle, double angle, triple angle, factorization, defactorization, compound angle. All these formulas we are able to use here to simplify this trigonometric expression. As it stands, all the terms are in the form of double angle formula, and this is nothing but the formula of what? Cos 2 theta. Now, according to property of inverse trigonometric function, cos inverse and cos will get cancelled. What is remaining term? 2 theta. But our example is in terms of x, and we have to differentiate also with respect to x. So we have to convert this simplest form in terms of x. So 2 keep it as it is. So theta can be replaced by what? Tan inverse of x. Theta can be replaced by tan inverse of x. In this way, we have simplified the given expression. Now we are able to differentiate it. So differentiate it with respect to x. So derivative of y is dy upon dx, keep 2 as it is, and we know that derivative of tan inverse of x is 1 upon 1 plus x square. Derivative of tan inverse of x is what? 1 upon 1 plus x square. Means differentiation is completed. Now let us simplify it. So dy upon dx will be equal to, now here nothing is there to simplify, only take this multiplication. 2 into 1 will be equal to 2. 2 upon 1 plus x square will be the required derivative. In this way we are differentiating the given function applying what? Substitution method. And in this example, what is our substitution? X is equals to tan theta. So prepare the list of all these formulas which we are able to use as an substitution, means if such type of expression appears in the example, at that time what value we have to substitute is also written here, and using this method we are finding differentiation. All the example from this question we have to solve using same method. Now see the second example. Here what is the function? Y is equal to tan inverse of 2x upon 1 minus x square. So what algebraic expression appears here? 2x upon 1 minus x square. 2x upon 1 minus x square appears. At that time what is our substitution? X is equal to tan theta. So let us substitute here x is equals to tan theta, means we are substituting x is equals to tan theta, which implies that if we are taking tan inverse on both sides, on this side tan and tan inverse will get cancelled, remaining term is theta, and on this side we will get tan inverse of x. This result we have obtained just by taking tan inverse on both sides. Now use this substitution in this example. So let us see what we will get here. So tan y is equal to tan inverse of 2 x I am replacing by tan theta upon 1 minus x square, means tan square theta, because we are substituting x is equal to tan. So here also replace x by tan. Here if I am substituting x is equal to tan, so x square means what we will get? Tan square theta. Now here we can observe that 2 tan theta upon 1 minus tan square theta is nothing but value of what? Tan 2 theta according to double angle formula. And here according to property of inverse trigonometric function, tan inverse and tan will get cancelled. What is the remaining term? 2 theta. So 2 keep it as it is. Now replace theta by what? Tan inverse of x. Replace theta by tan inverse of x. So this is the value of y. Once the value of y in terms of x is known to us, means in the simplest form is known to us, then we are differentiating both sides with respect to what? X. So differentiate both sides with respect to x. On this side derivative of y is dy upon dx, and on this side 2 keep it as it is, and we know that derivative of tan inverse of x is 1 upon 1 plus x square, so which can be written as 2 into 1 is 2, and in the denominator 1 plus x square, keep it as it is. Now 2 upon 1 plus x square will be the required derivative of this function. Now observe the example number 3rd. In this example, what is given function? Y is equal to sine inverse of 1 minus x square upon 1 plus x square. If 1 minus x square upon 1 plus x square appears in the given example, means if this expression appears, at that time what is our substitution? X is equal to tan theta. Means using this substitution we are able to arrange the term in the form of some standard formulas, and here already we in the last 2 example we have seen that if we are using this substitution, expression will get converted in the form of double angle formula. So if we are substituting x is equal to tan theta, then it implies that theta is equal to tan inverse of x. So now use this substitution in this example. So therefore y will become sine inverse of 1 minus, replace x by what? Tan. So x square will be equal to tan square, and in the denominator also replace x by tan theta. So here also we will get tan square theta. Just we have substituted the value of x is equal to tan theta in the given function. Now 1 minus tan square theta upon 1 plus tan square theta is nothing but value of what? Cos 2 theta according to double angle formula. So here what will get? Sine inverse of cos 2 theta. So which is equal to, here sine inverse is there, we have to convert this expression also in terms of sine, and we know that cos can be converted in terms of sine applying allied angle formula, and cos theta can be written as what? Sine pi by 2 minus theta. But what is the value of theta here? 2 theta, isn't it? So cos sine pi by 2 minus theta will be equal to cos theta, and we have converted cos in terms of sine. Why we are converting cos in terms of sine? Because here sine inverse is there, and now we are able to apply property of inverse trigonometric function, and according to our property of inverse trigonometric function, sine inverse and sine will get cancelled. What is remaining term? Pi by 2 minus 2 theta. But we have to simplify or we have to differentiate this function with respect to x. So let us convert this expression in terms of x, and to convert it in terms of x, replace this theta by what? Its value tan inverse of x. In this way we have converted the given function in the simplest form. This is the value of y. Now we are differentiating it with respect to x. So see what differentiation we will get. On this side, derivative of y is dy upon dx. Derivative of constant term is 0, minus 2, keep it as it is. Derivative of tan inverse of x is 1 upon 1 plus x square. So finally what result we are getting? Not necessary to write 0 here. Minus 2 into 1 is minus 2, and in the denominator 1 plus x square, keep it as it is, which is nothing but a required value of dy upon dx. In this way we have got the differentiation of this function. Now see the example number 4th. In this example, what is the given function? Y is equal to sine inverse of 2x into under root 1 minus x square. Let us check what will be our substitution. Means in case if the root appears, whatever maybe the substitutions are there are just to eliminate the root, and if roots are eliminated we are able to simplify that expression. So to eliminate this root we have to check that this expression is in this form, under root a square minus x square. Here a is what? 1. Here a is replaced by what? 1. 1 square is what? 1. So means, hope you are getting it. We have to use this substitution because this expression is in that form. But here instead of a, 1 is given to us, means value of a is what here? 1. And what is square of 1? 1. Isn't it? So on this side also we have to replace a by 1, means what will be our substitution? X is equal to sine theta or x is equal to what? Cos theta. We have two choices, either substitute x is equal to sine theta or x is equal to cos theta. Using any one of these two substitution we are able to solve this example. So as a stand I am substituting here x is equals to sine theta. Let us see what we will get. A sine theta, but a is what here? 1. So not necessary 1 here. So x is equal to sine theta is our substitution, which implies that theta will be equal to what we'll get? Sine inverse of x. Means this result we have got just simply taking sine inverse on both sides. If I'm taking sine inverse of left hand side, we will get sine inverse of x, and if we are taking sine inverse of right hand side, sine inverse and sine will get cancelled. Remaining term is what? Theta. Now substitute this value of x in the given function. So therefore y will become sine inverse of 2x, but x is what? Sine theta into under root 1 minus, again I am replacing x by sine theta, so x square means sine square theta. Just we have substituted this value of x in the given function. So now see what we'll get. Sine inverse of, keep this 2 sine theta as it is, under root 1 minus sine square theta will be equal to cos square theta. So according to our identity, 1 minus sine square theta is what? Cos square theta. So which is equal to, keep this sine inverse as it is, this 2 also as it is, sine theta also as it is. Now cos square theta outside the root will become what? Cos theta. And now here we can observe that this 2 sine theta into cos theta is nothing but value of what? Sine 2 theta according to double angle formula. Now simplifying it, we have converted it in terms of sine. Now we are able to apply the property of inverse trigonometric function, and according to property we can say that sine inverse and sine will get cancelled, and what result we are getting? 2 theta. So which is equal to 2, keep it as it is, theta can be replaced by its value. What is the value of theta? Sine inverse of x. Now value of y in terms of x is known to us. Now we are differentiating it with respect to x. So differentiate it with respect to x. On this side derivative of y is dy upon dx. On the right hand side 2, keep it as it is, and derivative of sine inverse of x is 1 upon under root 1 minus x square. Finally it can be written as dy upon dx is equals to, so 2 into 1 will be equal to 2 upon under root 1 minus x square. We know that derivative of sine inverse of x is what? 1 upon under root 1 minus x square. Once the differentiation is known to us, write down this expression in the simplest form. So 2 into 1 will become 2, keep denominator as it is. In this way we have got the differentiation of this given function. Now see the example number 5th. In this case given function is y is equal to cos inverse of 3x minus 4x cube. Now what is the algebraic expression appears here? 3x minus 4x cube. If 3x minus 4x cube appears, at that time we are able to substitute x is equal to sine theta. And if we are substituting x is equal to sine theta, what we will get here? 3 sine theta minus 4 sine cube theta. Means we are able to arrange the terms in the form of triple angle formula of sine. So let us substitute here x is equals to sine theta. So which implies that theta is equal to sine inverse of x. Okay, so if you are substituting these values in the given function, let us see what we'll get. Y is equal to cos inverse of 3. I am replacing x by what? Sin theta minus 4. Now again replace x by what? Sin. So x cube will become what? Sin cube theta. So which is equal to cos inverse, keep it as it is, 3 sin theta minus 4 sin cube theta is nothing but value of what? Sin 3 theta according to triple angle formula. So but here cos inverse is there, means we have to convert this sin in terms of cos, and sin can be converted in terms of cos applying allied angle formula. So we know that sin theta can be written as cos pi by 2 minus theta. What is theta here? 3 theta. So cos pi by 2 minus theta is sin theta. What is the value of theta here? 3 theta. Means sin theta can be written as cos pi by 2 minus theta using allied angle formulas. Now we have converted this expression in terms of cos. So according to properties of inverse trigonometric function, cos inverse and cos will get cancelled. We will get pi by 2 minus 3 theta. In this way we have simplified this function, but we have to differentiate it, and to differentiate it with respect to x, let us try to convert it in terms of x. 3, keep it as it is. This theta can be replaced by its value sin inverse of x. So this is the value of y. Now we are differentiating it with respect to x. So derivative of y with respect to x is dy upon dx. On this side, derivative of constant term is 0, minus 3, keep it as it is. And what is derivative of sin inverse of x? Derivative of sin inverse of x is 1 upon under root 1 minus x square. In this way, differentiation is completed. Let us write down it in the simplest form. Not necessary to write 0 here, and minus 3 into 1 will be equals to minus 3, and in the denominator 1 minus x square, keep it as it is. In this way, we have got the differentiation of this given function. Now see the example number 6. In this case, what is the given function? Y is equal to cos inverse of e raised to power x minus e raised to power minus x upon e raised to power x in plus e raised to power minus x. So first we will try to eliminate these terms of negative power using laws of exponent. So to convert terms of negative, or to eliminate terms of negative power, observe what is power of e raised to power of e is what? Minus x. And to eliminate this, we are multiplying to it by e raised to power x. Let us see what we'll get if we are multiplying to it by e raised to power x. So here base are same, so if you are taking addition of power, minus x plus x will become 0, and any number raised to power 0 will be equal to what? 1. Means to eliminate the terms of negative power, we have to multiply to numerator by e raised to power x, and since we are multiplying to numerator, that's why we are multiplying to denominator also by e raised to power x. So I am multiplying to numerator by e raised to power x. So here e raised to power x minus e raised to power minus x, keep it as it is, and since I am multiplying to numerator, that's why we are multiplying to denominator also by e raised to power x. So which is equal to, now see what we'll get here, e raised to power x into e raised to power x is square of e raised to power x, and minus, keep it as it is, e raised to power x into e raised to power minus x. Just now we have seen that e raised to power x into e raised to power minus x will be equal to what? 1. So its value will be equal to 1. In the denominator also, e raised to power x into e raised to power x is square of e raised to power x, plus, keep it as it is, e raised to power x into e raised to power minus x will be equals to what? 1. So which is equals to, otherwise now we are using substitution. So this expression is exactly in this form, only instead of e raised to power x, here x appears, isn't it? So if I am taking minus common to arrange the term in this form, पहले हमें क्या चाहिए? 1 चाहिए, तो 1 पहले लाने के लिए हमें क्या करना पड़ेगा? माइनस कॉमन लेना पड़ेगा. So we are taking minus common. So if we are taking minus common here from numerator, this negative term will become positive, and this positive term will become what? Negative. Okay, hope you are getting it. And in the denominator, a plus b can be written as b plus a, means we are able to apply commutative property in the denominator. Okay, just simply we have taken minus common from the numerator. Now this expression is in the form of 1 minus x square divided by 1 plus x square, but instead of x, what is there? E raised to power x. So on this side also we have to replace x by what? E raised to power x. तो हमारा substitution क्या होगा यहाँ पे? Put e raised to power x is equals to tan theta. Hope you are getting it. Instead of x, e raised to power x is there. That's why on that side also we are replacing x by e raised to power x. If we are substituting this value, let us see what we'll get. First, let us try to find out value of theta. To eliminate this tan, we are taking tan inverse on both sides. So if we are taking tan inverse on right hand side, so tan inverse of tan theta is theta, and on this side what we will get? Tan inverse of e raised to power x. Just simply we have taken tan inverse on both sides to find out value of theta. Now we are substituting all these values in y. So therefore y will become cos inverse of, observe the value of y, 1 minus 1 minus e raised to power x will get replaced by what? Tan. So here we will get tan, and the square keep it as it is, tan square theta, and in the denominator we will get 1 plus tan square theta. Okay, so which is equals to, now cos inverse keep it as it is, minus also as it is. Now 1 minus tan square theta upon 1 plus tan square theta is the value of what? Cos 2 theta according to double angle formula. This is the value of cos 2 theta. अभी हमें यहाँ पे माइनस नहीं चाहिए. To eliminate this minus, we are applying allied angle formulas. So try to understand how to make the use of allied angle formulas. Just minus is there. अगर minus नहीं रहता तो cos और cos inverse क्या हो जाता था? Cancel हो जाता था using property of inverse trigonometric function. लेकिन यहाँ पे minus है. So minus cos theta will be equals to cos pi minus theta. What is theta here? 2 theta. According to allied angle formula, cos pi minus theta will be equals to minus cos theta, but theta is what here? 2 theta. Means minus cos 2 theta can be written as cos pi minus 2 theta according to allied angle formula. So we have converted this expression in terms of what? Cos. Now using property of inverse trigonometric function, see what we'll get here. Y is equals to, now here this cos inverse and cos will get cancelled. What is the remaining term? Pi minus 2 theta. So now we are substituting the value of theta. What is the value of theta? Tan inverse of e raised to power x. Tan inverse of e raised to power x. Now we are able to differentiate it with respect to x. So differentiate it with respect to x. So derivative of y is dy upon dx. Derivative of this constant term is 0, minus 2 keep it as it is. Now observe this function is in the form of tan inverse of e raised to power x. Means instead of x, e raised to power x appears. Means even if x is replaced by any another term, at that time we can say that the function is in the form of tan inverse of f of x. So its derivative is 1 upon 1 plus square of f of x, means square of e raised to power x into derivative of f of x. What is f of x here? E raised to power x. F of x is what? E raised to power x. So which is equal to, now not necessary to write down what? 0. So here minus 2 into 1 will be equal to minus 2 upon 1 plus, according to laws of exponent, e raised to power x raised to power 2. So means a raised to power m raised to power n can be written as a raised to power m into n. Means 2 into x will become 2x, and we know that differentiation of e raised to power x is e raised to power x. I mean, now differentiation is completed. Just simplify it. So here nothing is there to simplify. Minus 2 into e raised to power x will become minus 2 e raised to power x, and in the denominator 1 plus e raised to power 2x, keep it as it is, which is nothing but the value of dy by dx. In this way, we have got the differentiation of this given function. Now see the example number 7th. In this case, what is the given function? Y is equal to cos inverse of 1 minus 9 raised to power x upon 1 plus 9 raised to power x. So here we are able to, we will try to arrange the term in the form of this formula 1 minus x square upon 1 plus x square. अभी x की वैल्यू क्या होंगी ये सिंप्लीफाई करके देखेंगे. So which is equals to cos inverse of, try to understand it very carefully, 1 minus, now 9 can be written as square of 3, so here we will get 3 square raised to power x. But according to laws of exponent, it can also be written as 3 raised to power x raised to power 2. ये power हम interchange कर सकते हैं using what? Laws of indices, or it is also called as laws of exponent. Means it 9 raised to power x can be written as 3 raised to power x upon whole bracket square, and 1 plus again in the denominator 9 raised to power x can be written as square of 3 raised to power x. 2 अगर अंदर लिया तो 3 का स्क्वायर वापस से क्या मिलेगा हमें 9. Just we are trying to arrange the term in the form of this expression. अभी x के जगह पे क्या है, यहाँ पे 3 raised to power x है, तो यहाँ पे भी हमें x के जगह पे क्या लिखना पड़ेगा 3 raised to power x. यानी हमारा substitution क्या होगा यहाँ पे, that 3 raised to power x will be equals to tan theta, which implies that let us try to find out value of theta from this substitution. So it will become tan inverse of 3 raised to power x. Just simply we have taken tan inverse on both sides to get this result, means value of theta in terms of x. Now substitute this value in y. So therefore y will become, y is equal to cos inverse of 1 minus 3 raised to power x, I am replacing by tan, so here we will get tan square theta, and in the denominator 1 plus again replace 3 raised to power x by tan, so here we will get tan square theta, 1 minus tan square theta upon 1 plus tan square theta, so which is equal to cos inverse of 1 minus tan square theta upon 1 plus tan square theta is nothing but value of what, cos 2 theta according to double angle formula. Now we have converted this expression in terms of cos. Now we are able to apply property of inverse trigonometric function, which says that cos and cos inverse will get cancelled. Then what is remaining term here? 2 theta. So which is equal to 2, keep it as it is. Now I am replacing theta by its value. What is the value of theta? Tan inverse of 3 raised to power x. In this way we have got the simplest form of this given function. Now we are differentiating it with respect to x. So differentiate with respect to x. Derivative of y is dy upon dx. On this side 2 is a constant term, keep it as it is. Now this function is in the form of tan inverse of f of x. So its differentiation is 1 upon 1 plus square of f of x, means square of 3 raised to power x into derivative of f of x. But what is f of x? 3 raised to power x. Now let us simplify it. So 2 into 1 will become 2. So dy upon dx will be equals to 2 divided by 1 plus. Now square of 3 raised to power x. According to laws of exponent, this 2 powers can be interchange. x यहाँ पे ले सकते हैं, 2 यहाँ पे ले सकते हैं. 2 अगर अंदर लिया तो 3 का स्क्वायर क्या होगा 9, and what we are getting 9 raised to power x after simplifying it, isn't it? इसकी वैल्यू कितनी है 9 raised to power x. 9 raised to power x can be written in this form, or this term can be expressed in the form of 9 raised to power x, isn't it? Now we are finding differentiation of 3 raised to power x. What is derivative of 3 raised to power x? It is in the form of a raised to power x. So its derivative is 3 raised to power x into log 3. So which is equals to, now multiply by 2 to this expression. So what will get 2 into 3 raised to power x into log 3 divided by 1 plus 9 raised to power x will be the value of dy by dx. In this way we have got the differentiation of this given function. Now see the example number 8. In this case, given function is y is equal to sine inverse of 4 raised to power x plus 1 by 2 upon 1 plus 2 raised to power 4x. Now we are trying to arrange the term in the form of some terms, and then we will use substitution method. So first let us simplify it. So which is equal to sine inverse of, observe the steps very carefully. So here numerator is in the form of a raised to power m plus n, which can be written as a raised to power m into a raised to power n according to laws of exponent. So 4 raised to power x plus 1 by 2 can be written as 4 raised to power x into 4 raised to power 1 by 2. Now observe the denominator very carefully. 1 plus, I am not disturbing to 2 here, but this 4x, can I write it as 2 raised to power x raised to power 2, because 2 into 2x will be equal to what? 4x, isn't it? So here keep this sine inverse, keep it as it is. Now observe the numerator very carefully. In the numerator we are not disturbing to 4 raised to power x, but 4 raised to power 1 by 2 4 raised to power 1 by 2 means what? Square root of 4. Raised to power 1 by 2 means what? Square root. And square root of 4 will be equals to 2. So here I am writing 2. So 4 raised to power x as it is, and value of 4 raised to power 1 by 2 means square root of 4 will be equal to 2. Now observe the denominator very carefully. 1 plus, here 2 raised to power 2 can be replaced by 4 raised to power x raised to power 2, keep it as it is. This x also as it is, this 2 also. Just simply square of 2 will be equal to what? 4. Now if you'll observe here, we have arranged the term in the form of 2 into f of x plus 1 upon square of f of x. So here means expression is exactly in the form of this term, 2x divided by 1 plus x square. Just instead of x, what is x here? 4 raised to power x, means x is replaced by 4 raised to power x. So on this side also we have to replace x by what? 4 raised to power x. Means our substitution will become, what will be our substitution here? Put 4 raised to power x is equals to tan theta. Hope you have got it, because x instead of x, here 4 raised to power x is there. That's why on this side also x I am replacing by 4 raised to power x. Let us substitute all these values in y, but before that let us try to find out value of theta. To find out value of theta, we have to take tan inverse on both sides. So tan inverse of tan theta is theta, and on this side we will get tan inverse of 4 raised to power x, isn't it? Once the value of theta is known to us, we are substituting all these values in y. So what is y? Sine inverse of 2, keep it as it is. This 4 raised to power x I am replacing by tan theta, and in the denominator also 1 plus, again 4 raised to power x will get replaced by tan theta, and the square keep it as it is. So which is equal to sine inverse of, now if you will observe this term, 2 tan theta upon 1 plus tan square theta is the value of what? Sine 2 theta according to double angle formula. So this whole term will get replaced by sine 2 theta according to double angle formula. According to property of inverse trigonometric function, sine inverse and sine will get cancelled. So what value of y we have got here? 2 theta. So now we are substituting the value of theta here. So y is equal to 2 theta. Theta will get replaced by what? Tan inverse of 4 raised to power x. So now differentiate it with respect to x. So differentiate with respect to x. So derivative of y is dy upon dx is equal to 2, keep it as it is. Now to find out differentiation, observe that this term is in the form of tan inverse of f of x. And what is derivative of tan inverse of f of x? 1 upon 1 plus square of f of x. What is f of x? 4 raised to power x. Its square means 4 raised to power x raised to power 2. 1 upon 1 plus square of f of x into derivative of f of x. What is f of x here? 4 raised to power x. 4 raised to power x will be our f of x, isn't it? So which is equals to, so 2 into 1 will be equal to 2, in the denominator 1 plus. So this term is in the form of a raised to power m raised to power n, which can be written as a raised to power m into n, means 2 into x will be 2x. And here derivative of 4 raised to power x is 4 raised to power x into log 4, because this term is in the form of a raised to power x, and we know that derivative of a raised to power x is a raised to power x into log a. So which is equal to, now here 4, observe this 2, observe this 2, can I write it as 4 raised to power 1 by 2, means square root of 4 will be equal to 2. 2 can be written as square root of 4. And here 4 raised to power x into log 4, keep it as it is, keep the denominator 1 plus 4 raised to power 2x also as it is. So which is equal to, in the numerator check that base is same, yes base is same, so we are taking addition of power, 1 by 2 plus x can be written as x plus 1 by 2 into log 4, keep it as it is, divided by, so here what we'll get, 1 plus 4 raised to power what? 2x. Nothing is there to simplify. That's why we can say that this will be our required differentiation. In this way we have got the differentiation of this given function. Now see the example number 9th. In this case given function is y is equal to sine inverse of 1 minus 25x square upon 1 plus 25x square. So we are trying to arrange the term in the form of this expression, 1 minus f of x square upon 1 plus f of x square. Let us see what f of x we are getting here. So which is equals to, so 1 minus 25x square, can I write it as square of 5x? Yes, square of 5 is what? 25, and square of x is what? X square. Means 25x square can be written as square of 5x. Same method we are applying in the denominator. In the denominator also 25x square can be written as square of 5x whole bracket square. So which is equal to sine inverse, keep it as it is. Okay, now we are able to use substitution method because this expression is in the form of 1 minus f of x square upon 1 plus f of x square. At that time our substitution is put f of x is equal to tan theta. So here we are substituting 5x is equals to tan theta. So which implies that theta is equal to, take tan on this side it will become tan inverse of 5x. If we are substituting all these values in y, so see what value of y we are getting. Sine inverse of 1 minus f of x I am replacing by tan. So f of x square means what result we will get here? Tan square theta, and in the denominator 1 plus tan square theta. Just simply f of 5x can be replaced by what? Tan theta. So which is equal to sine inverse, keep it as it is. Now here we can observe that 1 minus tan square theta upon 1 plus tan square theta is nothing but value of what? Cos 2 theta according to double angle formula. So replace it by cos 2 theta. But here sine inverse is there, means we have to convert cos in terms of sine. And cos can be converted in terms of sine applying what? Allied angle formula. In many examples we have converted cos in terms of sine. So cos theta can be written as sine pi by 2 minus theta. What is theta here? 2 theta. So which is equal to, now sine inverse and sine will get cancelled. What result we are getting? Pi by 2 minus 2 theta. So which is equal to pi by 2, keep it as it is, minus 2 also as it is. Just simply replace theta by its value, tan inverse of 5x. Tan inverse of 5x. And this is the simplest form of y, means we have converted y in the simplest form. Now we are able to differentiate it with respect to x. So differentiate it with respect to x. Derivative of y with respect to x is denoted by dy upon dx. Derivative of pi by 2 is 0. Minus 2, keep it as it is. Derivative of tan inverse of f of x will be equal to 1 upon 1 plus square of f of x. What is f of x? 5x. Into derivative of f of x. Here f of x is nothing but what? 5x. So which is equal to, not necessary to write 0. Now minus 2 into 1 will be equal to minus 2. In the denominator 1 plus square of 5x. Square of 5 is 25 and square of x is x square. And here derivative of 5x will be equals to 5. So which is equal to minus 2 into 5 will be equals to minus 10 divided by 1 plus 25x square. This is nothing but the value of dy upon dx, and which is nothing but our required differentiation. Now see the example number 10th. In this case, what is given function? Y is equal to sine inverse of 1 minus x cube upon 1 plus x cube. Here also we are trying to arrange the term in the form of 1 minus f of x square divided by 1 plus f of x square. So square should be required. Here square, instead of cube we have to convert it in terms of what? Square. And to convert it in terms of square we are using laws of exponent. So try to understand here. So here sine inverse, keep it as it is. Sine inverse as it is. In the numerator 1 minus x raised to power 3 by 2. I am dividing by 2 and that's why I am multiplying by 2. So hope you have got it. Again, if we are multiplying hereby, again if we are multiplying by 2, 2 will get cancelled and we will get x cube. This adjustment we are doing just to arrange this square, isn't it? We are multiplying by 2, that's why I am dividing by 2. Same method we are applying in the denominator. So here also what will get? 1 upon x raised to power 3 by 2 raised to power 2. Now we have arranged the term in the form of what? 1 minus f of x square upon 1 plus f of x square. So at that time what is our substitution? F of x is equal to tan theta. So we are substituting here. So put f of x means x raised to power 3 by 2 is equals to tan theta. So which implies that if we are taking tan inverse on both sides, on this side tan inverse of tan theta is theta and on this side we will get tan inverse of 3 by 2, isn't it? x raised to power 3 by 2, x raised to power 3 by 2. Now substitute this value of x raised to power 3 by 2 means tan theta in this expression, means y will be equal to sine inverse of 1 minus, replace x raised to power 3 by 2 by what? Tan theta. So keep this square as it is. So here we'll get 1 minus tan square theta in this denominator also. Replace this term by tan. So here also we'll get tan square theta. Now once it will get converted, algebraic expression will get converted into trigonometric equation. At that time we have to make the use of formulas from trigonometry, and here we can observe that 1 minus tan square theta upon 1 plus tan square theta is the value of what? Cos 2 theta according to double angle formula. Now here sine inverse is there, means we have to convert cos in terms of sine, and cos can be converted in terms of sine applying allied angle formula. So cos theta can be written as sine pi by 2 minus theta. What is theta here? 2 theta, isn't it? So here sine and sine inverse will get cancelled. Remaining term is pi by 2 minus 2 theta. So keep this pi by 2 as it is and minus 2 also as it is. Replace theta by its value. What is the value of theta? Tan inverse of x raised to power 3 by 2. Now this is the value of y. We are differentiating it with respect to x. Let us see what differentiation we will get here. Differentiate with respect to x. Derivative of y with respect to x is dy upon dx, and on this side derivative of pi by 2 is 0, minus 2 is a constant term. Keep it as it is. Now derivative of tan inverse of f of x, this x raised to power 3 by 2 is what? F of x. And what is derivative of tan inverse of f of x? 1 upon 1 plus square of f of x, means square of x raised to power 3 by 2 into derivative of f of x. What is f of x? X raised to power 3 by 2. Hope all of you are getting it. So which is equal to, here not necessary to write 0, minus 2 into 1 will be equals to minus 2. In the denominator 1 plus, keep it as it is. Here term is in the form of a raised to power m raised to power n, which can be written as a raised to power m into n if we are taking its product. So this 2 will get cancelled, means remaining term is here what? X cube. Now we are finding its differentiation. It is in the form of x raised to power n. In such cases, first we are taking power as an coefficient, means take 3 by 2 as an coefficient and decrease its power by 1. So if we are decreasing power by 1, means 3 by 2 minus 1 will be equals to 1 by 2. So here 2 and 2 will get cancelled. So remaining term is minus into 3 into x raised to power 1 by 2, means minus 3, minus into 3 is minus 3, and x raised to power 1 by 2 can be written as what? Root x, because raised to power 1 by 2 is the exponent which is used for what? Root. So root x raised to power 1 by 2 I am replacing by root x, and in the denominator 1 plus x cube, keep it as it is. So in this way we have got the derivative of given function. Now see the example number 11th. In this case given function is y is equal to tan inverse of 2 x raised to power 5 by 2 upon 1 minus x raised to power 5. So now this expression we are able to arrange in the form of 2 into f of x divided by 1 plus square of f of x. Let us try to arrange this term in this form. If we are able to arrange it in this form, then our substitution is f of x is equals to tan theta. So let us try to arrange the term in this form. So tan inverse of 2, keep it as it is, x raised to power 5 by 2 also as it is. In the denominator 1 minus. Now x raised to power 5. Check that. Can I write it in this form? X raised to power 5 divided by 2, means I am dividing by 2, that's why I am multiplying by 2. Again this 2 will get cancelled and we will get x raised to power 5. Now if we are doing this adjustment, means whatever may be the value of f of x is here, same value is here, means expression is in the form of 2 f of x divided by 1 minus square of f of x, means expression is in this form, isn't it? So here instead of plus, minus is required. So make the correction here, minus is there. Okay. So now if if the expression is in this form, at that time our substitution is what? F of x is equals to tan theta. What is f of x here? X raised to power 5 by 2. So our substitution is x raised to power 5 by 2 is equals to tan theta, which implies that theta is equal to, take tan inverse on both sides, so tan inverse of x raised to power 5 by 2. And if we are taking tan inverse on this side, remaining term will be theta. Now substitute all these values in y. So see what result we will get. So y is equal to tan inverse of 2 into x raised to power 5 by 2 means what? Tan theta divided by 1 minus, again x raised to power 5 by 2 will be equal to tan theta, keep this square as it is. So which is equal to tan inverse, keep it as it is. Now if you will observe this trigonometric expression, 2 tan theta upon 1 minus tan square theta is nothing but value of tan 2 theta. It is the value of what? Tan 2 theta. Now we are able to apply the property of inverse trigonometric function, that tan inverse of tan 2 theta will be equal to what? 2 theta, means tan inverse and tan will get cancelled. So this is the value of y. So which implies that y is equal to 2, keep it as it is, replace theta by its value. What is the value of theta? Tan inverse of x raised to power 5 by 2. Now let us differentiate it with respect to x. So differentiate it with respect to x. So derivative of y with respect to x is denoted by dy upon dx. On this side, 2 keep it as it is, 2 keep it as it is, and we are finding differentiation of this term. So observe this term. It is in the form of tan inverse of f of x. And what is derivative of tan inverse of f of x? 1 upon 1 plus square of f of x. What is f of x here? X raised to power 5 by 2, its square, into derivative of f of x. What is f of x? X raised to power 5 by 2. So which is equal to, now let us simplify it, 2 into 1 will be equal to 2. In the denominator, 1 keep it as it is, plus also as it is. Now here, if we are applying laws of exponent, x raised to power m raised to power n can be written as x raised to power m into n. If we are taking its multiplication, 2 will get cancelled, means remaining term will be x raised to power 5. And here we have to find out its differentiation, which is in the form of x raised to power n. So first take this power n as an coefficient and decrease power by 1. So 5 by 2 minus 1 will be equal to 3 by 2. So here this 2 and 2 will get cancelled. So in the numerator we will get x into x raised to power 3 by 2. X raised to power 3 by 2 can be written as x into x raised to power 1 by 2, because here nothing is there, means 1 is there. If base are same, we are able to take the addition of power. 1 plus 1 by 2 will be equal to 3 by 2, means x raised to power 3 by 2 can be written as x raised to power 1 into x raised to power 1 by 2. So we are not disturbing to denominator, keep denominator as it is, 1 plus x raised to power 5. In the numerator, 5x keep it as it is, 5x as it is, and this x raised to power 1 by 2 can be replaced by root x, and in the denominator 1 plus x raised to power 5 as it is, so which is nothing but derivative of the given function. In this way we have got the differentiation. Observe the last example from question number 9th. In this case, given function is y is equal to cot inverse of 1 minus root x upon 1 plus root x. First, we will convert cot inverse in terms of tan inverse, because maximum formulas in trigonometry, either half angle, double angle, triple angle, are available in terms of what? Tan. So that's why I'm converting cot inverse in terms of what? Tan inverse. And we know that to convert cot inverse in terms of what? Tan inverse, simply we have to take the reciprocal of this term, 1 plus root x upon 1 minus root x. Simply we have taken reciprocal of this term to convert cot inverse in terms of what? Tan inverse. Now we have one property, that tan inverse of x plus y, tan inverse of x plus y divided by 1 minus xy will be equal to tan inverse of x plus tan inverse of y. So let us make the utilize of this property here. So observe y is equal to, Now whatever, if plus is there in the numerator, if plus is there in the denominator, minus is required. Here also plus is there and in denominator minus is there. In denominator first term should be 1, so here already 1 is there, and second term should be the product of these two terms, product of what, x and y. So check whether second term is product of these two terms or not. First term is 1 and second term is what, root x, and 1 into root x will be what, root x, means these terms are exactly in the form of this formula. Here x is nothing but what, 1, and y is nothing but what, root x. According to this property, this expression can be written as tan inverse of x plus tan inverse of y, means can be written as tan inverse of x, x is what here, 1, plus tan inverse of y. What is y here? Root x. Hope you have got it. We are applying this property to simplify this expression. Once we have got the value of y in simplified form, let us differentiate it with respect to x. So differentiate it with respect to x. So derivative of y is dy upon dx. On this side, observe the first term. In the first term, x does not appear, means we can say that it is a constant term, and we know that derivative of constant term is 0. So derivative of first term will be 0, plus, now observe the second term. Second term is in the form of tan inverse of root x, means instead of x another term appears, we can consider it as what, f of x, means second term is in the form of tan inverse of f of x. And what is derivative of tan inverse of f of x? 1 upon 1 plus square of f of x into derivative of f of x. What is f of x here? Root x. So not necessary to write 0. So here 1 upon 1 plus, what is square of root x? Square of root x is x. Now we are finding differentiation of root x, and we know that differentiation of root x will be 1 upon 2 root x. So which is equal to, see what we are getting in the numerator, 1 into 1 is 1, and in the denominator first write down 2, then write down root x, and lastly write down 1 plus x. In this way we have got the differentiation of this given function. So in this way we have completed all the example from question number 9. So in the next video we are starting last question, question number 10. If you think that these videos are helpful to you, so please like the video and share these videos with your friends.